So we are dealing with question 3 of modern physics. When a beam of 10.6 electron volt photons of intensity 2 watt per meter square falls on a platinum surface of area 1 into 10 to the power minus 4 meter square and work function 5.6 electron volt, 0.53% of the incident photons eject photoelectrons. Find the number of photoelectrons emitted per second and their minimum and maximum energies in electron volt. So the first thing that we will be calculating over here is the energy incident on platinum surface. So energy incident on platinum surface. So this can be calculated as the intensity, that is 2 watt per meter square, into area, which is equal to 2 into 10 to the power minus 4 meter square. So this is the area which we are using and this is the value of intensity. So we get 2 into 10 to the power minus 4 watt. So this is the value of energy incident on platinum surface per second. Now the next one is a beam of 10.6 electron volt is used. So I can say that the number of photons is striking per second. So number of photons is striking per second can be calculated as the incident energy divided by the energy of one photon. The energy of one photon. So if we do this calculation, we obtain 2 into 10 to the power minus 4 upon the energy of one beam, that is 10.6 electron volt into 1.6 into 10 to the power minus 19. So from here we obtain it as equal to 1.179, which we are writing it as 1.18 into 10 to the power 14 photons per second. So this is the value of the incident photons per second. Now the next part which we are dealing with is saying 0.53% of the incident photons eject photoelectrons. So the next thing which I am calculating is number of photoelectrons emitted. Number of photoelectrons emitted per second. So now the number of photoelectrons emitted per second will become equal to 0.53%, that is 0.53 by 100 into 1.18 into 10 to the power 14. So we get a value equal to 6.25 into 10 to the power 11 photoelectrons per second. So the question that is asked over here is find the number of photoelectrons emitted per second, which we have obtained. The minimum and maximum energy is possible. So the minimum amount of energy which is possible in this case is going to be 0. So whenever the question is asking the minimum kinetic energy of the emitted photoelectron, then it is 0, and the maximum kinetic energy can be calculated as incident energy minus the work function. So incident energy minus work function can be written as 10.6 minus 5.6. So we obtain a value equal to 5 electron volt. So all the value of emitted photoelectrons can have the value ranging from 5 electron volt to 0 electron volt. So this is the maximum possible kinetic energy and the minimum possible kinetic energy is 0. It is because that during the course of the time when the photoelectrons are emitted from a metal surface and trying to come out from the metal surface, it can undergo collision with the so many things are there inside the metal plate, as a result of which it can lose all its kinetic energy and just manage to come out from the metal plate. So we say that the minimum amount of kinetic energy is 0 and the maximum energy is corresponding to the incident energy minus work function. So all the values of the kinetic energy between the maximum and the value 0 is possible for the emitted photoelectrons.